arithmetic or geometric? Isaiah. Getting used to the new seating chart. Why is it arithmetic? Because from term to term, the entire pattern adds 2. Miriam. Does this one have a constant difference or does it have a constant ratio if it's arithmetic? You got it. That's not fair. I'll come back to you. Can't call on someone who wasn't here yesterday. That's me. You were here though. Aubrey, what is the constant difference?
2. 10.
Carly, what is a sub 1? 5. What the heck does a sub 1 mean? The first number in the list. Okay, now we get to question 4, where I know a couple of you have it because we kind of talked a little bit, but many of you probably got stuck. Would that be a fair assessment? And that's perfectly accurate. Now, this is an arithmetic sequence, and if it's an arithmetic sequence, when graphed, what does it look like? Looks like a linear equation, just a bunch of dots instead of connected. And therefore, I used point slope form to help us out. I used point slope form because if you want to write a linear equation, generally you want y equals mx plus b. But that only works if you have the slope and the y-intercept, the m and the b. I don't have slope. I do have a bunch of points though. And if I have a bunch of points, can I calculate the slope? What's the formula for slope? That's slope-intercept form. Slope is just the m. How do you find m? Rise over run. Change in y's over changes in x's. y2 minus y1 over x2 minus x1. There's a lot of different ways to write it. These would be like my y's, these would be like my x's. How did the y's change to go from 5 to 7? To go from 1 to 2 in the x's, plus 1. And so change in y over change in x would be 2 over 1, which is 2. So, this is slope. Slope of this is 2. Okay? When you write a linear equation in the form y equals mx plus b, or in point slope form for that matter, 2 of the variables stay variables. Which ones? X and y. So this y right here is going to stay y. The m we just said was 2. This x right here, we're going to keep x. y1 and x1 are not intended to just straight up be regular variables. They're intended to be placeholders for y values and x values. They are supposed to become numbers. Don't care which point you use. I like small numbers. I'm going to use that coordinate point. This essentially is the x, this essentially is the y. So y1 would be 5, x1 would be 1. If you used a different coordinate point, it would look different at this point. But that is okay because in the end, it should look the same when you get y alone. If you used a different coordinate point, you'll get the same end result. Do not change it. Because generally, we don't want to leave something in an unsimplified form.
We just did it on this.
Or did I not?
She's in the wrong spot.
Oh, I didn't notice that you put the X and the Y in the wrong spot. My bad.
We should have just put the X.
Okay. This is the equation for the linear setup that hits these points. Now, arithmetic sequence. Is an arithmetic sequence the exact same thing as a linear equation? No. Linear equations are lines. Arithmetic sequences will look like they form a line, but it will be a bunch of dots. So I need to make a slight adjustment here because there's not actually an X and a Y. What should actually be here where my Y is? A sub n. What should be where X is? N. This is the equation for an arithmetic sequence. Specifically this arithmetic sequence. It looks like a linear equation. Instead of X and Y, it's got A sub n and n. Now, I had a fifth question on here that I kind of had hidden. I purposely didn't have it up there right away. What is the 500th term in this sequence? Thoughts on how we can find that? Kind of. Right direction, not quite right. I don't want to plug it in for A sub n because A sub n is a term in the list. Am I telling you that 500 is somewhere in this list? Could it be in the list? Sure. Will it be in the list? This is an arithmetic sequence that adds 2 starting at 5. Isn't every single number in this list going to be odd? Would 500 be in that list? No. I am telling you the 500th term is the number in the 500th spot. What letter represents where you are in the list? N. When I ask for the 500th term, I am looking for a sub 500. In other words, n is 500. What is a sub n at that point? So we're right on the idea of plugging it in, but I'm plugging 500 into n. A sub n equals 2 times 500 plus 3. The 500th number in this list is going to be 1003. Now, more accurately, we would leave this as a sub 500 equals 1003. If you leave it as a sub n, I'm not going to be upset about it. If you leave it as a sub 500, it is more accurate, but please do be careful and recognize that this is not a times 500. It is a subscript. It is telling us a location. So, today, we're getting into working with our arithmetic sequences. We are getting into doing this by writing equations and finding different positions of numbers. So, all of this builds itself off of working with linear equations because arithmetic look linear. .2 focuses on arithmetic sequences and series. Put the laptop away, please. Thank you. So today we're getting into working with the arithmetic sequence formula. It's technically called the explicit formula. No, that does not mean it swears. I know, bad joke. It's called an explicit formula because explicit in math means it tells us exactly what is what. There is another type of formula that comes with arithmetic sequences. It's called a recursive formula. We'll talk about that when we get to 10.5. The arithmetic sequence formula builds itself off of point-slope form. It builds itself off of this y minus y1 equals n times the quantity x minus x1. Now, first thing I want to focus in on a little bit is the slope. We said the slope of this equation when it was linear was 2. Where do you think that came from in reference to the sequence? Where is 2 important in reference to the sequence that goes 5, 7, 9, 11? It's adding 2 every time. Slope in a linear equation is like the constant difference of an arithmetic sequence. Now, the other thing that happens is they don't really keep this piece here, this number here on this side. They get that what would be a sub n, because that's what this would be. That would be a sub n. They get it alone. They move this piece over. Now, I could go through and I could continue to derive exactly where this comes from, but for the sake of time, a modified version of the point slope form, changing the variables to what it would work for in arithmetic sequences and getting the a sub n alone, it would end up looking like this. Remember, a sub n represents the nth term or is equal to the equation. We call it the nth term because we don't know what position n is talking about. N specifically is the position. It's where in the list a number is. A sub 1, therefore, being the first number or the first term in the list. And D being that constant difference. You're going to see a couple different sets of instructions today. One of which will be write an equation for the nth term. When they do this, they could give you information in a couple of different ways. They could just start by giving you the beginning of the list. Now, if they give you the beginning of the list, I highly recommend, because we have more than just arithmetic equations, even though that is our focus today, you should get in the habit, though, of checking, is it arithmetic? 7, 12, 17, 22. Is that an arithmetic sequence? See some head nods. How do you know? Yep, it's plus 5 every time. Now another thing technically we should start checking is it a sequence altogether? Is it a list of numbers with pattern? Yes. That's going to get more important once we start learning about series. Okay, so it's arithmetic sequence, which means if I want to write an equation for the nth term, I'm using this formula. Much like when you write an equation in point-slope form or slope-intercept form, some things are going to stay letters. A sub n and n will stay letters. A sub n equals. What's a sub 1? 7. It's the first term, so 7 plus n is going to stay n minus 1 times 5. D was 5. Much like with linear equations, we don't generally leave them in a form like this. We want them simplified. If I want to simplify this equation, what am I going to do? Distribute, and then I will combine like terms. A sub n equals 7 plus 5n minus 5. Combine like terms. A sub n is equal to 5n plus 2. Sometimes, when they want you to write this equation, they're going to give you a term in the list and the constant difference. Now, in order to write my equation in this form, a sub n and n stayed letters, but a sub 1 and d had to become numbers, so I need both d and a sub 1. I have d, but I don't have a sub 1, which means I need to find a sub 1 first. There's a couple ways to find a sub 1. One option is just start writing out the sequence, and in this case, work backwards. Now that's perfectly okay when I give you a sub 5, but if I give you a sub 50, we would be here for a long time to work backwards, to go back from the 50th term and find the previous 50. Another option we can use is we have a formula. We have a formula, a sub n equals a sub 1 plus n minus 1 times d. We know d is 6. A sub 1 is missing. The question is, do we know an a sub n and an n that correspond to one another? The answer being yes. We know a sub 5 is 19. If a sub 5 is equal to 19, that means n equals 5 when that a sub n equals 19. That's what that term means. Which means I can plug 19 in here and 5 in here. And now the only thing that's missing is my a sub 1, which is the thing that we needed in order to write this equation. If I want to solve for a sub 1, where should I start? You could distribute, but that's the hard way. Look at the stuff in the parentheses. Are those like terms? Yeah, then I would just combine them. Save yourself the distribution. You want to distribute, it'll work. That becomes a 4. I don't need the parentheses anymore because 4 times 6 is the same as 4 in parentheses times 6. It's 24. Negative 5 is a sub 1. Was a sub 1 what we were actually looking for as in the grand scheme of things? No, we were wanting to write the equation. We needed a sub 1, but we want to write the equation. When you go to write the equation, a sub n and n stay letters. We plug stuff in if we need. If we need to find missing things. But when we go to write the equation itself, I change them back into letters. I plug in my a sub 1, I plug in my d, and I simplify. One other set of instructions you'll see today. And it'll be find the nth term. They could do this a lot of different ways. One option is they tell you exactly what term they're looking for, a sub 20. When a sub n is equal to 4n minus 7. Which term am I looking for? The first, the second, the 8th, the 20th. This notation, again, means n is 20. What's a sub n? You know what n is, and you have an equation, you just plug it in. In this case, you'll get 73. Sometimes they won't give you the equation to work with. In fact, that's going to be a little more often than not. They're just going to give you some information. I'm looking for the 50th term. If I'm looking for the 50th term, what variable are they telling me right there? N equals 50. If I'm looking for the 50th term, it's telling me what is actually the thing that I don't know. A sub 50. In other words, a sub n is my question mark. I have this equation. A sub n is the question mark. That's the thing that's going to stay a variable. Do I know what a sub 1 is? Yes, what's a sub 1? 9. We already established we know what n is, 50. Do we know what d is? 7. From term to term, it increases by 7. Once you have all those things plugged in, can you figure out what a sub n is? Yeah. I do my minus in my parentheses. I do the multiply. And I add. A sub n is 352. Now again, more accurately, it's a sub 50. You leave it a sub n, I'm not upset. Chapter 10. It's going to be not very uncommon that as we go back and forth from day to day, you're going to have a long day of notes followed by a short day of notes. Tomorrow is going to be the short day. So, just as an FYI. That's kind of how things are designed.